We went to Chesilbeach in Dorset to find out how the beach profile changes between the proximal and distal end of the bar. We also investigated how the beach sediment size changes between the two ends. Chesilbeach is 17 kilometres from its proximal end to its distal end.
I'm here on Chesilbeach, world famous Tombolo, and currently we're standing at the proximal end. And as you can see, over in the distance there we have Portland, which is actually at the distal end of this bar. Behind Chesilbeach is a big lagoon which was formed by the deposition of the sediment which has formed Chesilbeach.
To measure the gradient of the beach, I'm going to use a gun kilometre. That's this one here. I'll simply aim with that one. We have two range poles, if you can see. Carefully held by Match House and James Hatch. I'm now going to simply pull and aim at the equivalent point on the second pole. Pull and release. That's a recording of 15 degrees. 15 degrees.
This is the calipers I'm going to use to measure the rocks on the beach. The way I'm going to do this is I'm going to measure the B-axis of the stone sample. I'm going to place it in the caliper, like that. I'm going to take a reading from here. As you can see, that one's 3 centimetres. I'm going to do that every 5 paces down the beach towards the sea.
My colleague James just explained we're going to measure the B-axis. Now what is the B-axis, some of you might say? Well, the A-axis is the biggest gap here between the rock, okay? The B-axis is then the middle distance there, as shown here, and the C-axis is the smallest one, as shown here, okay?
As you can see from the graph, the beach at the proximal end is much shorter and the ridges less pronounced. This is due to there being less wave energy because this end of the beach is sheltered. The smaller amount of wave energy means that only the small material is washed up onto the beach. This sediment size means the beach cannot hold its shape very well. This explains the shallower gradient.
At the distal end, the beach is much larger with a higher volume of sediment. The ridges are bigger and have a steeper gradient due to the larger sediment size. The sediment is less likely to be washed away because it is heavier and requires more energy to be moved. The sediment is larger at this end because it is less sheltered and the wave action is more powerful.
These are stones from the distal end and these are stones from the proximal end. Notice the difference in size. The reason for the greater size of the beach sediment at this distal end is because the wave energy here can move larger sediment, and at the proximal end, the lesser wave energy moves smaller sediment.